Hello friends, here the topic is application of differential equation, and in this video I'm just going to discuss the concept of increasing and decreasing function, like how such functions are giving you some interval where they are increasing and where they are decreasing, and how we are using some differential equation in order to find out their positive or negative gradient. So let's start. So here your question number first, the problem number first in front of you, that f of x is equal to minus of x square minus 2x plus 15. Find the interval where the function is increasing or decreasing. So let's see guys that how we can find out and by the which method. And here in especially in increasing and decreasing function, we always use the first derivative methods, nothing else. So let's see. Here the function is given to you, that is f of x is equal to minus of x square and minus of 2x and plus 15. So first of all, we need to find out the derivative of this function, or we can say the first derivative. It will becomes minus of 2x and minus 2. And according to the methodology of increasing decreasing functions, we will substitute as first derivative is equal to 0. So from this equation, you can see your this part will becomes minus 2x and minus 2 is equal to 0. And here your minus 2x will becomes equal to 2, and easily we can calculate the value of x, and that will becomes minus 1. Clear? Now, in order to find out interval of increasing and decreasing function, first of all you need to make a real line, a straight line. I'm just making here. You have to take a straight line, and here you will plot a point. Any point you have find out from f dash x is equal to 0, you have to plot on the real line. This is your real line. Always we have to take in the case of increasing and decreasing function. And here the minus 1 is the point, and I'm just considering my minus 1 point will be lie here. Like minus 1 is there, so you can see the 0 will be there and 1 will be there, and similarly minus 2 will be there. But our point is that is minus 1. Now what we have to do actually, so this is our existence point, that is minus 1, which we have find out from this equation. So now you need to know at which part your derivative, like first order derivative, is giving you a positive or negative value. So let's see my dear friends. First of all, after minus 1, your interval is from this part to this. From this side of real line, like after minus 1, I'm just going to check it out. My derivative, first order derivative, is positive or negative. And how we can find out? Let's see. Like minus 1, after minus 1, you got a point 0 or 1. So any point you can take and you will substitute in the f dash x. So what is our f dash x? That is minus of 2x and minus 2. So if I'm gonna find out your f dash at 0, you can see it will gives you 0 and it will gives you negative. So it is a negative result. Or any other point also you can consider, like f dash 1, you can find out it will gives you minus 2, 1 into minus 2, and here you got a minus 4. This is also negative. So what I'm taking here, so if I'm substituting any value after minus 1, like 0, 1, whatever the value I'm taking in the f dash x, in each and every case your f dash x is giving you a negative value. So your f dash x is giving you negative result. Getting your point? So now time to find out some values before minus 1. Here I'm considering you can take any value, any point before minus 1. So from this side I'm just taking the minus 2. So here you can see if I'm substitute in f dash, that is minus 2, what will becomes? So minus 2 into minus 2, minus 2 into minus 2, and having minus 2. So it will gives you plus 4 minus 2, and it will gives you 2. That is positive result. So here you got your f dash x will gives you positive value. Getting your point? It will gives you positive result. But what is it positive? F dash x. So if f dash x positive here, so it means this part is giving you a function increasing value. Okay, so here the function will increase, and at this part the function will decrease. If you got a negative, so function will decreasing, and here your function will increasing. So here I got an interval. Easily we can write out that function will increasing if x belongs to, now you can see that where from minus infinite to -1, like from up to -1, this complete function will gives you a increasing gradient or positive gradient, you can say that. Or if we are talking about the decreasing function, and this function will start to decrease if your x belongs to -1 to infinite. Am I right here? So after -1, this function is start to decrease, and here your function is increased. So this was the first problem for your questions. Let's start from the next question. Let's see. Here your question number second in front of you. 2x cube minus 9x square plus 12x and plus 15. Find the interval where the function is increasing or decreasing. So the question is same, but let's see how much point we can find out from this equation with the help of a first order derivative method. Let's see. My dear friends, first of all, you need to find out the derivative of the function, and here the function is given to you, that is 2 of x cube and minus 9 of x square and plus 12 of x and plus 15. And here you will find out the first order derivative, and it will gives you 6 of x square and minus of 18x and plus 12. Now you have to substitute the first order derivative is equal to 0, and here I'm just substituting this is equal to 0. After that you can see 6 will be common, and you can say x square and minus of 3x and plus 2 is equal to 0. This is your required equation. Now I can easily solve out this equation with the help of factorization. So it will give you x square minus 2x minus x and plus 2 is equal to 0. So here we can easily solve out this equation, and your result will becomes like x I can take common, and x minus 2 and minus 1 you can take common, and x minus 2 is equal to 0. So here you can see it will becomes x minus 1 and x minus 2 is equal to 0. And by this equation you got x is equal to 1 and x is equal to 2. So my dear friends, you can see there are two value of x we got. So it means now we need to make a real line, and we have to plot these 2 points there. Let's see. This is my real line now, and I will plot these 2 points on my real line. So here I'm considering that 0 will be there and 1 will be there, as well as 2 will be there, and after that you got a minus 1, whatever. So I have only 2 points, that is x is equal to 1 and x is equal to 2. So I will go through this from value of f dash x near about 1 and 2. Let's see how. So our points are 1 and 2. So I'm just marking my 2 points, that is 1 and other is 2. So it means now I have to find out my first order derivative like f dash x at which interval that is giving you positive value and which interval it is giving you a negative value. Let's see. So if I'm taking some point before 1, like from this part, any point you can consider. And what is my f dash x? My f dash x was 6 of x square and minus of 18x and plus 2. So any value you can consider. I'm just taking 0 here. I'm taking 0 here, so you can see it will become 0, minus 0 and plus 12. So it will gives you a positive gradient. So your f dash x will be positive here. Am I right here? where f dash x is positive. Let's see, if I'm taking any value and that is after 2 you can see you can put any value like 3. I can substitute here. So if I'm substituting in f dash x, that is 3, so what it will becomes, 3 3 is a 9, becomes 54 minus gain 54 and plus 12. So it all again it will gives you positive grade. So again your f dash x is positive here. Am I right here? Your f dash x is positive. So here your f dash x is positive before 1, and after 2 again your f dash x is positive. So now point is that what about this interval? Let's see. Now we are talking about this part, at which this interval your function will be, f dash x will be positive or negative grade. So any value you can take, like you can take a 1.5. I'm just taking 1.5 and substitute in f dash, that is 1.5 or half. I can say 6 into half means 1 by 4 minus 18 into half and plus 12. So the complete result will becomes 3 by 2 and minus 9 and plus 12. So here you can see, if you are calculating all the data, so the results will gives you negative value. New point, this complete results will gives you a negative value. So your f dash x will be negative point. So it means here you can see it will gives you negative of f dash x. You can solve out it, this complete part. I hope so you will easily solve out this part. Logic clear? So even when you are getting a negative value from this part, so easily you can say that at which interval your function is increasing, at which interval your function is decreasing. And how we can write out this? So for increasing, this interval becomes what? We are talking about increasing interval. So for increasing, you can say that it will be start from minus infinite and it will be moves for 1. So minus infinite to 1, minus infinite to 1, and here you have some break because here the function is decreasing, and after 2 it is again start. So you can say that it will gives you union and start from 2 to infinite again. So this complete interval gives you a increasing value, and if you are talking about decreasing, so easily you can say that from 1 to 2. Okay, so in each and every question your method is same, first order derivative, and you have to make a real line. Okay, let's see the another example. Here your problem number third, that f of x is equal to log of 1 plus x minus 2x by 2 plus x. How you can find out the value where the function is increasing and decreasing? Let's see guys. First of all, we need to calculate the derivative of the function, that is f dash x. It will becomes log will becomes 1 by 1 plus x, derivative of log of x, and here you can use u by v method. So it seems like that 2 plus x and having whole square, and 2 plus x will same, and 2x will gives you 2 and negative 2x will remain same and 2 will gives you 1. Let's solve more up from this equation. 1 by 1 plus x minus 2 2s are 4 and 2x and minus of 2x and divide by 2 plus x and having whole square. Little bit more we can solve out this equation, and here you got a 1 by 1 plus x and minus 2x will cancel with 2x, so 4 by 2 plus x and having whole square. Clear? And here I can take LCM. It will gives you 1 plus x and 2 plus x and having whole square. It will becomes 2 plus x having whole square and minus 4 into 1 plus x. Clear? A little bit more we can sort out, and we can open this square as you got a 4 plus x square and plus 4x and minus 4 and minus of 4x and divide by 1 plus x and into 2 plus x and having whole square. So after solution you got a result like that. 4x will cancel by 4x and also 4 will cancel by 4. So here you got a result that in the form of x square and 1 plus x and 2 plus x and having wholes. Logic clear? Now this is your required derivative of the function f dash x you got from here. So now what is the next step? So now the step is that we have to substitute f dash x is equal to 0. As we are substituting f dash x is equal to 0, so from this part you can see your this equation like x square and divide by 1 plus x and 2 plus x square will equal to 0. Now listen to me. If you have some fractional function and you are substituting is equal to 0, so directly you will not use the cross multiplication and you did not do this kind of things like 1 plus x into 0, it will become 0. Okay, so one point you have to note it down here. This function is not defined somewhere. Function is not defined somewhere, and the points are, if you are substituting minus 1 from here, so it will gives you 1 by 0, and if you are substituting minus 2 here, it will again gives you 1 by 0 something. It means we have some 2 point where the function is not defined. Okay, add x is equal to minus 1 and x is equal to minus 2. Like if you are substituting minus 1 here and if you are substituting minus 2 here, in both case your function will not define. You can say that at the point this and this, our function will not define. So it means these 2 points are such important for us now. Okay, so we will keep in mind these 2 points. So now I'm just going for to equation number 1, as I'm just considering this equation number 1. Now from first you can do the cross multiplication, and this complete part will go to 0 in the multiplication of 0 and it will become 0. So here you got x square is equal to 0, and from this part you got a value of x that is 0. So from equation number 1 we got a result of x is equal to 1, but with this result we have 2 other point where the function is not defined. So it means these 2 points are also important for us. Okay, so these 3 points we will keep in mind, and these 3 points are we will use in order to find out increasing and decreasing interval for this function. So let's see, my dear friends. So here we have 3 points, 0, minus 1 and minus 2. So let's see. So we have 3 points now. One is x is equal to 0, one is x is equal to minus 1, and other is x is equal to minus 2. So now you need to make a real line. I'm just making a real line, and I'm just going to plot all the points like somewhere is 0, here the point is 0, here the point is minus 1, and here the point is minus 2. All the points I just plot here. So now you need to find out at which intervals this function is giving you a positive gradient or negative gradient. Like at this part we will check it out, at this part we will check it out, as well as this part we will involve, and this part we will involve. Clear? Let's see. Now what was your f dash x? That was a complete value that was in the fraction value. So our f dash x was x square divided by 1 plus x and 2 plus x and having whole square. This was your derivative of the function. Now see, so we have to check it out at this interval at this and this and this. So first of all, we will find out the value of this f dash x at before minus 2. So here you got somewhere the point that will be minus 3. So it means you can check it out, your function, your f dash x at minus 3. If you are substituting minus 3, so what will becomes? So here you got a positive, and here you got what? Minus 3 you are substituting, it will negative value. But here you got what? A square, so it will become positive. Here is a positive, here is positive, and here it will gives you negative. So complete result will gives you negative. You can substitute minus 3, so you can check it out. Okay. And after that, I'm going to find out minus 2 to minus 1. So it means you can find out minus 1.5 somewhere. Okay, like minus 1 to minus 2, minus 1.5. It will also gives you, because here you can see negative minus 1.5, it will gives you negative value. It's a positive, both will gives you positive, but it will gives you negative, so it will again be negative. Okay, and after that, I'm just finding from minus 1 to 0, or you can say that f of minus 0.5. Minus 0.5, what it will becomes? So minus 0.5, x square will gives you positive, this is having all square, it will gives you positive, but here if 1 plus minus 0.5, it is also positive, because 1 is greater than minus 0.5, so here you got a positive result. Similarly, if you are substituting a value more than 0, like I'm substituting 1 here, so this always gives you positive. Clear? So my dear friends, your f dash, I'm talking about your f dash. So f dash x is a negative, your f dash x will negative in this interval, but here your f dash x will positive, and here your f dash x will gives you positive. Okay, so here you got some intervals where the functions is positive gradient and where the function is negative gradient. So it means I can substitute, I can find out the increasing and decreasing value. So where it is increasing and where it is decreasing. So where it is increasing, let's see. I'm talking about increasing. Let's see where the positive values, these are positive. We start from minus 1. So let's start from minus 1 and minus 1 to 0. And one point more, you could not involve minus 1 and 0. Okay, minus 1 and 0, these are the turning point. You could not involve these 2 points. So that's why always use a open bracket. Open bracket is showing to you that 0 is not involving in and minus 1 is also not involving in. So after 0 is also again start from increasing function. So minus 1 to 0 union 0 to infinite. This complete interval gives you a increasing functions. Okay, and if we are talking about decreasing value of this function, so here you can see these both are negative. So start from minus infinite and we will go up to minus 2, and then we will start union and minus 2 to minus 1. So this is your required answer for this question. So I hope so that now with the help of 3 problems, you understand the concept of increasing and decreasing functions. After this, we will start the maxima and minima of such kind of functions. So thank you so much for watching this, guys. Bye bye.